Yes, welcome to the VLSI course. We'll see the course overview. So in the first unit, we are going to see the MOS and VLSI technology, that is NMOS, CMOS, PMOS, BiCMOS, gallium arsenide, various fabrication steps. In the unit 2, we are going to see the stick and layer diagrams of various digital logic circuits with the help of Boolean expressions. Next, in the unit 3, we are going to see what are the basic circuit concepts like sheet resistance, capacitance, delay parameters, and choice of layers. In the unit 4, we are going to discuss what are the various scaling parameters and mass circuit, scaling of mass circuit, subsystem designs of adders, multipliers, ALU, arithmetic logic units, memory elements, SRAM, DRAM, and in Unit 5, you are going to see what are the various CMOS testing and testability, like digital design for testability and built-in self-test, all these parameters. Okay, next, what are the course outcomes? These are the course outcomes from we are going to learn. Students can able to learn after all the 5 units. After reading all these 5 units, these are the course outcomes students can able to achieve. Next, we are going to see what are the design objectives. That is, what is the history and what is the IC, what is VLSI, how it is going to achieve. We are going to discuss. Next few minutes, we are going to learn new concepts that is called VLSI technology. So first, history of what are the various technologies and how VLSI is introduced. What are the basic technologies before VLSI? So first in 1947, that is BJT is introduced, that is bipolar junction transistor. It is very small size, that is it is having three terminal device. Before BJT, we are having vacuum tubes where the TVs or radios are very big size. It is wall based, so the initial developments the size is very large. So the major VLSI is introduced because of reducing the size. Next, in 1958, the first IC is introduced. IC is nothing but a small, it is integrated circuit. It is invented by Jack and Kilby, that is JK. In 1963, that is first CMOS logic gates are introduced, that is 7400, all the basic logic gates are introduced. In 1970, the first microprocessor, that is Intel 4004, is introduced. That is, we are having P1, P3, P4 desktop systems based on the microprocessor. In 1970, the 8 VLSI, that is first VLSI chip is introduced. It is having greater than 10 power 5 transistors. So next we will see what is an IC. IC is nothing but integrated circuits. We will see what are the various classifications of this IC. So first we are having SSI, that is called as small scale integration, where the IC consists of 10 square, that is 100 transistors per chip. Examples are gates and flip-flops. Next we are having medium scale integrations. So it is having 10 power 3 transistors per chip. Examples are counters, multiplexers, and registers. Next we are having large scale integrations. So it is having 10 power 4 transistors per chip. Examples are 8-bit microprocessor. Next we are having VLSI, that is 10 power 5 transistors. Rather than 10 power 5 transistors, examples for this is 16-bit and 32-bit microprocessors. Next we are having ultra large scale integrations, that is up to 10 power 7 transistors per chip. That is, we are having virtual reality modules. These are used in present VR modules and AI, artificial intelligence and VR are latest technologies. They are used in all the technologies. Next, you're having GSI, that is gained scale integration, which is having 10 power 7 transistor, greater than 10 power transistor per chip. Okay, next we are see next few minutes we are going to say why VLSI used and what is VLSI. So VLSI is basically we are going to package more number of devices in smaller areas. Next, to fabricate the chips for latest electronic applications like smart mobile phones, iPads, all this with a high speed design, high processing speeds. Next, in VLSI, you're having various design levels, that is RTL, register transfer level, physical and layout designs. Physical and layout designs are the next future technology, that is already we are having later so many jobs in this area, that is front end and back end, they are also called. Next, in VLSI, we are going to study various languages, that is VHDL, very high speed hardware descriptive language, Verilog, Verilog HDL, System Verilog, UVM. These are the languages uh, are used for front end designs. Next, various tools are used as Cadence, Synopsys, Xilinx. These are the popular tools. Are used other tools also there, but these are the major popular tools are used in VLSI front end and back end. So front end and back end we are having simulation and synthesis tools. They are also called as simulation and synthesis. Next, why you are going to use VLSI in the industry? Major, we are having three design parameters, that is called as APT. A stands for area. Area is to reduce, to make small size, we have to decrease the area. So area is also related to the size. Next one is power. Because all the upcoming technology devices are used for more battery life. Okay, you have to decrease the power, the operating battery power should be decreased. And next third parameter is that is time or delay. Delay is related to the speed. If the delay is small, the processor speed is more. So the major three parameters in VLSI is APT. Okay, other parameters are also there, but these are the major areas in VLSI sector. How these parameters are varied or achieved, and how VLSI chip is fabricated. Okay, another we are having PVT corner. These are the three design parameters. Or based on these parameters, we can achieve this above all these three parameters. At a time, it is not possible. Either you can concentrate on any one parameter, either area, power, or time. One is process, doping process. Next one is threshold voltage. These are the variables. By changing any one of the parameter, we can achieve area, power, time in the VLSI chips. And other design flows are ASIC and CAC. ASIC stands for Application Specific Integrated Circuit. CAC stands for Customized Integrated Circuit. Where ASICs, by using ASIC design flow, we can go into fabricate analog digital ICs, and with the help of CAC, we can go into fabricate analog ICs. Next, we'll see what is the design flow, that is basic ASIC design flow. ASIC stands for Application Specific Design Flow. So first, the vendor, X vendor is given specifications. X vendor means in the process we are having Intel, AMD, Xenon, all the various processors. So the X company will give the specification to the VLSI team. So in the design specification, they will give the area, speed, and what is the power consumption, that is what should be the battery operating voltage. All these are design specifications are given by specifications team. Okay, the specifications, from the specification that is given to the RTL team. RTL is nothing but register transfer language, that is where based on the specifications this team will develop Verilog code, and from there it is given to the functional simulation team. where based on the Verilog code that will be verified by using various software tools, simulation tools, the functionality of the specifications are verified. So functionality means according to the truth table or behavior, they will check the functionality, and from the functionality that is given to the synthesis team, where the Verilog code, the hardware language is converted into netlist file. Synthesis is output file, from the synthesis is netlist file, where the RTL code is converted into netlist file. Next, from the synthesis, it is given to the timing simulation. Timing simulation, again, the timing delay related parameters are observed. And from these timing simulations, it will be given to the DFT. DFT is one of the fault finding technology that is designed for testability, where the faults can be observed. This left side, all this part is called as front end design, and the right side, all the blocks are called as back end design. So VLSI, you are having various, these are the two basic domains that is called as front end and back end. Front end, all the simulation part that is they are done, and back end designing and layout part will be developed. That is, first one is floor plan. Floor plan means based on the this specifications, the floor is allocated. How much area should be allocated without any wasting the area. So how you can going to effectively use the area that is taken by floor planning, and it is also done by all the tools. Again, we are going to use different tools, encounter and virtuoso. These are the different tools are used for synthesis. Assura, all these tools are used for backend tool. And next, from the floor planning, we are going to see power planning. So power planning, all the VDD, VSS, all interconnects are connected or properly, that will be verified. Based on the power planning, again, there will be placement will be there. Placement, it is also exactly proper utilization of the area, and optimization techniques are used in the placement techniques. From the placements, we are going to see CTEC, that is clock tree synthesis, where again synthesis will be done. That is second synthesis, that is also called CTS. Next, after CTS, you are going to see the routing. Routing means all the various interconnects are connected to the all the submodules or subblocks. Next, we are having from the routing, we are having DRC or LVS. DRC stands for design rule checker, and LVS means layout versus schematic checker. Design rules means based on the all the internal layers, that metal layers, polysilicon, gate layers, or having the minimum gaps or minimum width, all are followed or not. So if any mismatch is there, it will give the errors. So DRC or LVS should be verified. So any errors in the above stages, it will give the errors, and wherever the errors are there, again it will fed back to the previous stages. If it is LVS is verified okay, then only you can go for the XRC, that is called as RNC extraction, that is resistor and capacitor extraction. From there, it is going to develop GDS, that is graphical data stream information interchange. It will be the final fabrication chip which will be given to the fabrication team, where they can fabricate the chips. So in India, we are having very less number of fabs. Generally, we are sending this all the GDS files to Taiwan, Singapore, Malaysia, all these countries. Next, what are the various applications where you are using these VLSI applications? These are the examples, that is processors, CPU, DSP controllers, various processors, memory chips, RAM, ROM, EEPROM, analog mobile communications, programmable logic gates, that is FPGA field programmable gate arrays, embedded systems, used in cars and factories. Next, system on chips, medical equipments, consumer and industrial applications, smartphones.